So now let's learn how we can estimate the slope of a curve when we are given a function here rather than a table. So go ahead and grab your graphing calculator and let's pause the video if you need to. Go ahead and sketch the curve f of x equals 3 divided by 1 plus x squared on your graphing calculator. And then we'll go ahead and put the sketch here in our notes as well. Now notice I am spacing out my tick marks quite a bit because I want to have a large enough graph that I'm able to actually sketch my tangent line fairly accurately. So for this particular curve, it looks like at 0, we are up at 3. At 1, we are at 1.5, 1.5. And then at 2, we are at 3/5. And that's in the first quadrant alone. And then you'll notice that this particular graph is symmetrical to the y-axis. Remember, we would call this an even function because it has that y-axis symmetry. So just a rough sketch here so you can get an idea of what the graph is going to look like and then what the tangent line is going to look like. And this graph appears to level off in both directions, heading towards y equals 0. So our point of tangency is the point 1 comma 3/2, so 1 comma 1.5 right here is where we want to basically draw our tangent line and we want to determine the slope of the tangent line. And remember, to draw the tangent line is just going to touch the curve at this point. And in fact, I'm going to call this point P. We like P for the point of tangency. And pretend like you are driving your car at night along this curve and you're going to stop at point P and your headlights are going to shine in front of you and your tail lights behind you. And that path that your headlights would follow, that essentially is your tangent line. So here's a rough sketch of this tangent line, and we want to determine the slope of this line. I like to have the visual because it's nice to look at this graph and see that this tangent line has a negative slope. So we have an expectation that our answer is going to be a negative value. So if we end up with something positive, we immediately know we've done something wrong just by looking at our diagram. Now, we cannot determine the slope of this line because we only know one of the points on the line. So we're going to go ahead and move over a little bit and choose a second point. And by choosing a second point, we'll be able to create a secant line. So let's say I choose this point when x is equal to 2. The second point, I'm just going to label it as Q. And if I connect P to Q, now this is a secant line, and we should be able to determine the slope of this secant line, which is the line PQ. So my first slope that I'm going to compute essentially is going to be from x equals 1 to x equals 2. So if we look at the two coordinates that I'm going to use, I have point P. So point P is the coordinate 1 comma 3/2. And because I am going to end up using my calculator, I'm going to go ahead and write that as a decimal. And then point Q, I let x equal 2, but I do need to figure out this y value here. This is a question mark. And remember, my y value would be found by just substituting 2 into this function. Now, rather than actually computing that right now, I'm just going to write the y value as f of 2. Whatever that output is, we'll just write that as f of 2. So then the slope of PQ will be computed by taking the change in the y values. So f of 2 minus 1.5 divided by the change in my x values, which will be 2 minus 1. So go ahead, grab your graphing calculator, pause the video, do this computation, and then write down your slope. And this gives us a slope of negative 0.9. Now, this isn't a bad estimate for the slope of the tangent line at point P, but we'd like to get a little bit better estimate than this. So we're basically going to go look at our graph and we're going to take point Q here and we're just going to move it along the curve a little bit closer to point P. So let's say we move it instead of x equals 2, what if we go right in the middle here and we go x equals 1.5 and we make this our new point Q? So now when we connect P to Q, we have a secant line, another secant line. But our secant line here will have a closer estimate for the slope of the tangent line than our previous estimate. So now we're essentially computing the slope from x equals 1 to x equals 1.5. So point P didn't change. That's a kind of our anchor point. The point of tangency is the same. But point Q has changed because now the x value of point Q is 1.5. And the y value will be whatever f of 1.5 is. So now the slope of our secant line PQ will be f of 1.5 minus 1.5 divided by 1.5 minus 1. So again, pause the video, go to your graphing calculator, and I am going to go ahead and show you in a minute how to do this efficiently on your graphing calculator. But let's go ahead and get this slope. And this should be approximately negative 1.1538 if I write down 4 decimal places. So notice the slope is still negative, but this should be a better estimate for the slope of the tangent line than our previous estimate. And now we're going to go ahead and do the same thing. We're going to continue moving point Q along the curve, getting closer to point P. So point P is the point 1, comma 1.5. So now maybe we'll go from x equals 1 to, let's say, x equals 1.1. So point P is still 1, comma 1.5. Point Q now is the point 1.1, f of 1.1. And our slope of PQ
is f of 1.1 minus 1.5 divided by 1.1 minus 1.
And that
And
works
that
out
works
to be
out to be
approximately
approximately
negative
negative
1.4253.
1.4253.
So now that we've done this computation 3 times, hopefully you can see essentially what's changing each time. We're just changing that second x value, and we're letting that second x value get closer and closer to x equals 1. And so that really just changes the coordinate of point Q each time. And we're looking at our outputs, these slopes of the secants here at the end, and we're hoping to start to see a trend, to see if these values are getting closer and closer to a specific number. And right now I can't see a very clear trend, so I'm going to have to do this computation a few more times. So for example, we're going to go ahead and compute from x equals 1 to x equals a little closer to 1, which would be 1.01. And we will do this again from x equals 1 to x equals 1.001. So next, I'm going to grab my graphing calculator and show you how to do all of these computations as efficiently as possible on the graphing calculator. And we are going to organize our information in a table. So let's set up the table before I show you the calculator. Now, our table is going to contain the x interval that we are analyzing, and then it will contain the slope of the secant lines, which is the slope of PQ. So for example, the first computation was the x interval from x equals 1 to 2, and our slope was negative 0.9. Our second interval was from x equals 1 to x equals 1.5, and our slope was about negative 1.1538. So once you do all of these slope computations, we want to go ahead and organize the results in a table so we can see if we are going to have a trend. So our next two that we're going to fill in will be from x equals 1 to 1.01, x equals 1 to 1.001, and I have a hunch we may even do one more, x equals 1 to 1.0001. So now let's grab our graphing calculators again.
So now let's make sure you feel comfortable with the graphing calculator portion of this problem. We'll want to go to our y equals and first enter in our function. And I'm going to demonstrate how to do this on a TI-84 I'm on the TI-84 Plus, the color edition. This works on any TI-84 that has been updated. If your calculator hasn't been updated, I will show you your keystrokes in a second. So because our function has a fraction, because it's rational, we want to use our shortcut menus. And these menus are F1, F2, F3, and F4. And they're green, so you're going to access those by using your alpha button. So alpha, and then choose F1, which is above your y equals, and this is your fraction shortcut menu. So we're going to choose number 1, which is going to create a nice vertical fraction for you. Now, if you go alpha F1 and you do not get that shortcut menu, that just means that your calculator has not been updated. If you have a TI-84, those calculators can be updated, and you can either do that by going on the TI website or linking with another TI-84 calculator that has been updated, and we can do that in person. If you're on a TI-83, those calculators cannot be updated. So I'll show you the keystrokes in just a second. You'll use your arrow buttons to just move between the numerator and the denominator. So we're entering 3 divided by 1 plus x squared as our function. And that's using, again, that vertical fraction notation. Now, let me just show you. I'm going to show in the Y2 how I would do this if I'm on a TI-83 or if I'm on an older TI-84 calculator. So on a TI-83, you'll have to enter your fraction horizontally. So 3 divided by, and then be sure to put parentheses around everything that's in the denominator. 1 plus x squared will need to be in parentheses like so. And then remember, before you use your graph button, always choose the zoom button first and choose number 6, which is zoom standard. And here's the graph that we had sketched earlier on this problem. And you could certainly adjust your window as well. So now we're going to second quit, and go back to our home screen. So the first slope that we computed was from x equals 1 to x equals 2. So to do this on your home screen, you're going to go ahead and use the fraction shortcut menu again, alpha F1. And then we wanted to input f of 2. So the way we do f of 2, which is function notation on the graphing calculator, is you're going to use, again, another shortcut menu. This time it's F4, the fourth shortcut menu. So alpha F4, and you'll choose Y1 because that's where we have our function stored. And then you put parentheses with the 2. So Y1 of 2 is the way the calculator reads this, but this is the same as us putting in f of 2, the way we wrote it on paper. So f of 2 minus 1.5, that was the change in our y values, divided by 2 minus 1, that was the change in our x values. So that's what we had written on paper, but now we're just doing that in the calculator. Our first slope was negative 0.9. So then we would do that again, alpha f1, choose that fraction shortcut key, and then alpha f4 to get our function notation. So our second slope was from x equals 1 to x equals 1.5. So we had f of 1.5 minus 1.5, all divided by 1.5 minus 1. So this was the slope that we had for our second secant line, and we rounded to 4 decimals. We had negative 1.1538. And then rather than typing this in repetitively, you also could arrow up and highlight the previous computation and press enter. And that's a much easier way rather than typing everything. Arrow back and then up, and you could certainly just change your input here because our third one was from x equals 1 to x equals 1.1. So we could change this 1.5 into 1.1, and remember to do the same in the denominator, and that probably would save you a little time. That way you don't have to type this in again. So we were wanting to do from x equals 1 to x equals 1.01. So let me show you how you can go up, grab your previous entry, arrow back and into that numerator. Now here we need to change this 1.1 into 1.01. So we need to insert a character. If I were to just type a 0 here, it would replace the value that I have. So I'm going to have to use the insert feature on the calculator, which is INS right here. It's above the delete key. So I'm going to use the second button since this is in blue, and I'm going to insert a 0. And that lets me then insert the 0, and that becomes 1.01. And then I'll do the same in the denominator. So second insert, inserting a 0 is another kind of shortcut on the calculator so you don't have to type everything again. So here's our slope from x equals 1 to x equals 1.01, negative 1.4925. You'll want to enter in your table. Let's compute again from x equals 1 to x equals 1.001. And again, I'll show you how to do this on a TI-83 in just a moment, or anybody else who doesn't have an updated TI-84. So second insert, this time insert another 0, and do the same in the denominator. There we go. So now we have negative 1.49925 for x equals 1 to x equals 1.001. And then let's just do it one more time so you really can start to see that trend to see what are those slopes all approaching? What value are they getting closer to? So I'm just continuing to use that insert feature to insert another 0. So now we're really, really close to x equals 1. And now we have negative 1.49925. So hopefully you can see all of these slopes. They look to be getting very, very close to negative 1.5. So it appears the slope of our tangent line is negative 1.5. So if you have an updated TI-84, you guys are done. You can leave the video. But now I want to go ahead and show how to do this for anyone with a TI-83 or a TI-84 that has not been updated. So for you all with a TI-83, you have your function entered horizontally. Then you're going to second quit and go back to your home screen. And you want to put in the slope here from x equals 1 to x equals 2. However, since you don't have that vertical fraction notation, you're just going to enter it horizontally, which requires an extra set of parentheses. So we'll need parentheses around the entire numerator and then parentheses around the entire denominator. Now, to get your function notation, since you don't have that F4 shortcut menu, you can access it from the vars key here. So find your variable key that says vars and choose vars. Then you're going to arrow to the right to y vars. And then you're going to choose number 1, function. And this is your list of your y1, y2, y3, and so on. And you'll choose y1. So there's a few extra keys for you guys, but I'll do that keystroke again, and you will use this sequence so frequently in our class, especially, that it'll become second nature. So this is basically f of 2 minus 1.5. That was the change in my y values. Close your parenthesis, divided by, open another parenthesis for the denominator, and that was 2 minus 1 in the denominator. And this was the very first slope that we computed, which was negative 0.9. So let me show you that again. So open a parenthesis. It's the vars key, then arrow to the right to y vars, select number 1, which is function, and then select number 1 again. So this is the slope from x equals 1 to x equals 1.5. So we wanted f of 1.5 minus 1.5. Close your parenthesis for the numerator, divided by, open your parenthesis for the denominator, 1.5 minus 1. Excuse me, I entered 1.2. Let's fix that. 1.5 minus 1. There we go. Which was negative 1.1538. Now, once you've gotten used to those keystrokes, rather than typing that again, you guys are not able to arrow up like we did, but you still have that capability on the calculator right here above the enter key where it says entry in blue. So try hitting second entry and see how it will bring up your previous entry. And then you are able to go back in and just change those x values. So our third slope was from x equals 1 to x equals 1.1. So you could change this to 1.1 in the numerator and then also change it to 1.1 in the denominator. And that would be the slope, the third slope we computed. Again, that was second entry to pull up your previous entry. And now we could go from x equals 1 to x equals 1.01. And this is where you'll use the insert feature. So second, insert, which is above the delete key, and then you'll insert that 0 where you need it. And in the denominator again, second, insert, put a 0 in there, and here's your next slope, negative 1.4925. So then go ahead and do this 2 more times for x equals 1.001 and then x equals 1.0001 just to make sure you've got it.
Now we're back in our notes and we can fill in the remaining slopes in our table that we just got from our calculator. So for x equals 1 to x equals 1.01, the slope was negative 1.4925. Our next slope was negative 1.49925. And our last slope was negative 1.49925. So looking at our table, we can see as we look at the x intervals here, these intervals are getting smaller. From 1 to 2 is a unit of 1. From 1 to 1.5 is a unit of 0.5. So these intervals are all getting smaller as x is getting closer and closer to 1. And then we need to analyze what's happening over here for our slopes. And hopefully you can see that these slopes are approaching negative 1.5. So the slopes approach negative 1.5. Therefore, we're going to say that the slope of our tangent line is negative 1.5. We used a bunch of different slopes of secant lines to then estimate the slope of our tangent line. So next, let's go on to part B, where we write the equation for the tangent line. In part B, we want to write the equation of the tangent line. So we know our slope is negative 1.5, and we have our point here, which is 1 comma 3/2, which we had been writing as 1 comma 1.5. So I find it's easiest to write your equation using the point slope form of a line, which remember is y minus y1 is equal to my slope times x minus x sub 1, where the x sub 1 and y sub 1 are the coordinates of the point that you know. So in this case, we would have y minus 1.5 equals my slope, which was negative 1.5, times x minus 1. And in my class, this is a perfectly acceptable answer. However, if your instructor wants you to write your equation for the line in slope-intercept form, then you would just go ahead and distribute. So I'll show that too. Distribute your negative 1.5, which will give us negative 1.5x plus 1.5, and then just add 1.5 so that you are isolating y. So the slope-intercept form of this line is y equals negative 1.5x plus 3, and this is another acceptable answer, just in a different form.